So this is part 2 of the Netconf and Yang tutorial. Part 1 gave an overview and background. Now we will focus purely on the Netconf protocol. Then later on, part 3 of this tutorial will go into Yang. We will start by looking at Netconf and compare it to other protocols and network management protocols that are typically mentioned in the industry. And we will look at from different perspective. What kind of standard is it? In what way do we identify the resources? And resources, I mean, that could be an interface, for example. And that's fundamental to any network management protocol, that you need to reference resources according to the data model. What kind of data models exist? What's the language to do the modeling? What are the management operations for the protocol? The underlying encoding and transport. Again, let's start with SNMP. It's a well-defined standard by IETF, been in place, it's deployed. And you can run test suits to validate that your device is actually adhering to the standards. Resources in SNMP are identified by object identifiers. It's been useful, but it's sort of painful at the same time. You don't say /interface is /interface /eth0, rather 1.3.6, etc. So that's a little bit awkward, but it works. The data models are defined in MIBs. MIBs are written in the SMI data language, and we have the SNMP protocol ops, get, next, set, etc. And we have a binary encoding, and SNMP is connectionless over UDP. Let's start by putting Netconf parallel to SNMP then. Same standard organization, and it's sort of an evolution where IETF realized we need something that can do configuration management, not only monitoring. In Netconf, you identify resources with paths that can be read and understood. So not a binary sort of, not an OID, but /interfaces /interface /eth0 again. So that's an obvious improvement for humans. Data models, there are starting to appear some core data models from IETF, and of course vendor-specific data models. And the data modeling language is Yang, of course, and it's carried over Netconf. SOAP was kind of popular a year ago or so, especially driven by vendors, I would say, that the management interface towards the device should be SOAP. If you compare that, that's a W3C standard. How do you actually refer to resources? A little bit undefined. That's not sort of the way SOAP interfaces are defined. SOAP defined functions are not seriously focused on a data model and well-defined identifiers for the resources. So I leave it empty here. The same with data models. There are a few data models sort of from various standard organizations, but not in general. And there is no specific data modeling language. WSTL, it's actually not data models, it's more the functions that you define in WSTL. The actual management operations are within this actual schema. You need to look at the schema, and you need to search for the request within the schema. They are not first-class citizens like in SNMP and Netconf, and the encoding is XML. Now the industry has turned to REST. REST is much simpler, so why do people leave SOAP and go to REST instead? And I would say the one primary argument is simplicity, and it's certainly very easy to use REST APIs if they're well defined. Note well that REST is not a standard, it's a set of design principles. So this means that you can never interrupt test a REST server. Is this REST or not? Well, sort of, because it's a set of design principles. Good design principles to some degree, but still not standardized. Resources over REST, that's one of the simple things. That's URLs. So in the same way, almost like in Netconf, you have URLs, and when you operate over a REST interface, you identify the interface using a URL to that interface. So that's pretty handy. We have no data models for this, and that also goes in line with sort of the REST simplicity. there is no requirement for a data modeling language. The response back can be text, can be XML, can be JSON encoded. Some use WADL for doing some kind of data modeling. The operations in turn are the standardized HTTP operations. So those are the operations you use. And the encoding, as I said, could be XML or JSON. So it's simple to use. You can use it from various command line tools, etc. The ease of using URLs to identify resources make it easy to use. What could be mentioned as a side note here is that we'll see, maybe in a couple of years, we see something like RESTconf being standardized. There is being worked upon a little bit slightly to map Netconf over REST. Note well, this is not standardized and not something you should jump into today. Let's see what the future brings. Today, Netconf is the thing that is standardized. Using SNMP again. In SNMP we had get, in Netconf we had get config, in SNMP we had get next, set, etc. And isn't this sort of just yet another RPC? Well, not if you study it more carefully. There is semantics embedded in the specific operations over Netconf. The first thing you should note is that over SNMP there is no separation between configuration data and operational data, whereas in Netconf you have explicit operations to work with config data. If you look from a bigger picture at the use cases that is easy to be supported over SNMP or Netconf. Can I get status fields over SNMP? Yes, you do typically get next over a table, but you need to iterate several times in order to get the data. If you use Netconf, you can just do one request to get huge XML encoding of the complete table in one go. And remember, it's very efficient over SSH and compacted, so it's not slow. And if you do some measurements, you'll see that doing a get of operation data over Netconf is typically 10 times faster than over SNMP, because it's one request and you don't have to iterate over the network. Can you set several configuration fields in SNMP? Yes. You need to put them into one SNMP set, the limit of the UDP package. In Netconf, you can build arbitrary large configurations over edit config. And moving on to next line, this can be arbitrary large. Everything with one edit config is a transaction, and you can have several edit configs and do a commit later on. So over Netconf, you can trust that everything will happen or not. So it's a transactional edit config. In SNMP, the var binds within one set are considered to be transactional, but those are so few, so you can't do large config changes. And even worse, can you do config changes across several network elements in SNMP? No, but that's achieved by using Netconf. Also, what you should recall here is that in SNMP you're typically very dependent on ordering. Those of you that have tried to do some sets over SNMP and realize that there are some hidden dependencies in which ordering you need to do things, that is totally removed over Netconf. Actions. In Netconf has explicit support for doing RPC calls, as they are called. So doing self-tests, reboots, those are explicit operations. There are tweaks to support that over SNMP, typically a set to a specific variable, but that creates very odd models. Notifications, well, yes, of course, the famous SNMP traps over UDP. In Netconf, they are connection oriented, so there are pros and cons. I mean, if you have a large network, probably you don't want to stay connected to every device in case they want to send a Netconf notification 1 year later. So this is a trade-off. What's the purpose of the notifications? And so UDP notifications still is very useful, I would say. Can you use SNMP for backup and restore? No, no one does that, to be honest. Perfect fit for Netconf. You can get the config, you can store it, and you can restore it by an edit config. Secure, yes, Netconf runs over SSH, well-established security framework. Version 3, SNMP is okay, but it's complex. So the complexity of version 3 typically pushes people back to version 1 and version 2. Remember the requirements initially from the operators being able to distribute configurations before committing them, to validate them, etc. In SNMP, everything takes immediate action. Whatever set you do, it immediately takes effect. In Netconf, you can send an edit config and you can validate it and you can commit it later on. So let's deep dive into transactions, because that's fundamental in Netconf. That was a primary requirement from the operators. And the typical ACID, the 4 properties that defines a transaction, the ACID properties. Atomicity means that it's all or nothing. It's an atomic change set. So when you do something over Netconf in an edit config, it's all or nothing. Consistency. This means that there is no ordering requirement from the client. A client can send create A, create B, or create B, create A. These are identical operations. So you can see it as one consistent change. So if a specific device requires ordering, it's not a transactional device. Independence. If you have ongoing transactions, they do not destroy each other, they do not interfere. So from an external observation point of view, it looks as though things happen in sequence. Of course, things are parallelized internally, but to the effect at the end is as if they appeared in sequence. Durability. It means that if you commit the data, it's there, it's persistent. So if you reboot a system, the configuration is still there. Just to take an example, if you give an interface a name or a number, some of you that are listening in here might recall some interesting scenarios where you reboot the system and the IF index in IF table suddenly is renumbered. Or if you remove an interface and stick another interface in, and the interface numbers are renumbered. Configuration data as part of a transaction is persistent, it sticks. So taking this into more of an example, consider a transaction where you would like to add an interface ETH5 and add a route to that. If you do it add the route over ETH5 and then ETH5 or vice versa, in a transactional context over Netconf, it doesn't matter. You can do any order and it's up to the device to perform the transaction correctly. So this releases the burden for management system. Just prepare the config and send it. We talked about backup and restore. So if you have a true transaction system, you can just dump the config. That can be huge and it looks like an ordering, but you should be able to take that same config and paste it in to the same or another system, and it will appear the same way. And you shouldn't be able to resort the data. It should be all or nothing and no PDU size limits. And then let the transaction span devices. Imagine you would need to create a service across several devices and applications. So in the network management system in the OSS, you should be able to prepare the configuration changes, some edits on the IPTV servers, routers, firewalls, and the billing. And the OSS can then just send that to the 4 devices without considering ordering. It's an all or nothing across all devices. Every device validates its configuration. And the management system can utilize validation and rollbacks that are supported in transaction systems to make sure that if one of the involved devices fail, it's easy to roll back on the other ones. So network-wide transaction, this is fundamental, and this is what makes Netconf stand out, especially to SNMP, but to RPC mechanisms in general, etc. You need to have transactional semantics on top of the network management protocol to make it easy for the management system to use it. So that was a little bit of the characteristics. Let's now move on to the explicit Netconf operations. Netconf messages are encoded in XML, so it's sort of an XML RPC where you have requests and responses with XML tags. And there's a framing mechanism. In 1.0, there was a character sequence. there were identified some corner cases where this actually didn't fly in XML, so there is another framing in 1.1 where the actual number of characters to read are specified. They are encrypted and carried over SSH. So the SSH framework is reused, so authentication and everything just runs over SSH. There were some historic mappings, including SOAP, but those are all deprecated. Netconf is SSH today. That's it. And it gives you authentication, integrity, and confidentiality, which is, of course, fundamental. And Netconf is connection-oriented. So, well, that's sort of the contrast between UDP, SNMP, and TCP. In this case, there's a TCP, and you don't have to take care of missed requests. The resends are managed automatically. And there's efficient use of the medium as well. It's always a balance when you specify a protocol, and if you release one protocol the day after, the creativity needs some new features. So that's built into Netconf, where whenever a Netconf client and Netconf server connects, they exchange their capabilities by the hello message. So both the client and server exchanges hello messages where their capabilities are expressed. And that can be both which standard things they support, but also private extensions. So the Netconf specification itself defines a couple of capabilities that are published as the hello. And interestingly enough, and very important, the Netconf server exposes its Yang data models to the Netconf client. That's also a capability. So which data models are supported by device, say hello, you'll get a list of the data models back. So this tells the management system explicitly which data models to use. Also, for example, can I write to the running database, or do I need to write to the candidate database and commit that to the running? Does it support validation, etc.? All of that is part of the hello. And all extensions have separate XML namespaces, so that's make it easy to avoid clashes. I did mention the examples of logical data stores. I might use the term database sometimes. That's a little bit sloppy in this tutorial. The correct name should be data store. And remember, these are pure logical data stores, and they are named. And this is something typical for networking devices, that they have a startup database, they have a running database which corresponds to how they behave currently. They might have a candidate database, and you can use URLs, etc. for data stores as well. By supporting Netconf, you must support the running data store. Startup and candidate, they are optional, and those are capabilities. We will do a hello exchange pretty soon to see how our device responds with data stores. Can you write directly? So writable running means that you can write directly to the running data store. And if you can't write directly, you need to use the Netconf operation copy config from one data store to another. So every Netconf operation refers to a data store. You specify the target, the name of the logical data store, and then the operation you would like to achieve. Connecting back to the discussion around transactions. When you do a transactional change, the manager can prepare a set of configuration changes, or just a complete bulk configuration, and you put that into one operation, the edit config. Edit config is sort of very fundamental here. So you put that into the edit config, and it can create a completely new configuration, or merge a little bit of bits and pieces into an existing config. And remember, probably this is the fourth or fifth time I say it, but it's well worth repeating. There is no need for the manager to figure out ordering. That's up to the device. And the device should also be able to recover. So it's not up to the manager to realize that half of the edit config went through. It's an all or nothing. But that's very important. So from a management perspective, it's an all or nothing. Remember the ACID characteristics. And so this makes it possible for a network manager to actually do a network-wide transaction, as we did see previously. You send a configuration change to every device to the candidate data store. Then you can ask each candidate data store to validate itself. If everyone says OK, you can then commit it to all devices. That's the simplest way of doing a network-wide transaction. There is also another more advanced, so to speak, commit operation, which is called confirmed commit. One use of the confirmed commit is that it covers cases where you, as a network admin, actually configures yourself away from the box. If you commit something and then suddenly you lose connection to it. The confirmed commit asks the device to commit the change into the running, go active with that configuration, but if the device does not receive sort of an ACK within the specified time, it will automatically go back to the previous one. So that covers the case where you configure yourself away from the device, but you can also have other tests running and you can monitor KPIs, etc. And if you're not happy, you can just drop the connection and the devices will automatically roll back. So that's a requirement in a confirmed commit. The devices should roll back if you drop the connection. Okay, let's go to the details now. What are the actual operations? These are the Netconf operations. Get. A get operation points somewhere in the data model tree, data store tree, and retrieves everything, configuration data as well as operational data. Get config, however, will only retrieve the configuration data, and this is fundamental. Just take the scenario of a backup and restore. You don't have to yourself sort of remove the operational attributes out of the response. Get config gives you the config. Edit config. Obviously, that's a way to manipulate the config, and you can delete and add and modify. It goes with a couple of options here. So you can have the test option, what should happen. Should you test and then set, or should you just blindly set, or should you only test and then return? Some error options, and you can also specify an explicit operation such as delete, etc. Copy config is used to copy configuration data from one data store to another, for example, from running to startup. Commit. Commit is actually an operation towards the candidate data store. So if a device supports candidate, you can do several edit configs towards the candidate database. Then at a later stage, you do a commit. The commit copies the candidate data store to the running. So that's what it does. You don't commit towards the running, you commit towards the candidate. If you've done a set of edit configs towards the candidate and want to get rid of those, discard changes empties the candidate database. Delete config, that's deleting a complete data store. You can lock and unlock data store to make sure that you have exclusive access to it. And there are two ways of either gracefully or tough killing a session. How does this look actually? So this is an example of a Netconf conversation. The manager sends a request. There is a message ID field that is used to correlate requests and responses, so they can go in parallel. So you match the message ID to match the requests and responses. So here we have an operation towards the candidate data store. Test then set, rollback and on error, so transactional behavior. We set the attributes of an interface, and the payload is always within the config. So there is a target section and there's a config section, and the config is the actual data, and this must correspond to the data model. In this specific case, must correspond to the Yang data model. Here's the OK. Then the management system asks the device to validate the candidate. OK. Finally, the management system performs a commit confirmed. OK. Typical sequence. And since this was a confirmed commit, to make this happen and not roll back automatically, the management system must also send a final commit within the time frame. There are a couple of optional capabilities here. So write to be running means that you can write directly to the running data store. That's still possible, even though a device has a candidate. You might still be allowed to write it to the running directly. Candidate, we mentioned that a couple of times. Confirm commit, we just talked about that, meaning you can commit with a timeout. Roll back on error, so it gives, if you do a complete edit config, the device will roll back if you have problems. Validate, you can send the config and then ask the device to validate it. Startup database. URL, meaning you can use URLs as data store. This is of course handy to have a config on a TFTP server or something, and you can copy that directly to the data store within the device. XPath. XPath is a complex filtering language, so a device, it's optional to support it, and if it's supported, the management system can send complex queries to select specific parts of the config when retrieving the configuration. There are some non-base standards, notification and interleave, meaning the spontaneous notifications, partial lock to do partial locks of the data store, default values, and an interesting one, Netconf monitoring. I would say the most important part of that is that if a device supports Netconf monitoring, the management system can dynamically retrieve the data models over the wire. I did show that in the introduction to this tutorial. And so the hello message gives you the name of a data model, and that's required. But if you support this capability, you can also get the actual data model. And vendors can define their own capabilities. So now we will look at the individual Netconf operations one by one, see the payload of the request and response. First, we have the famous hello operation. So in this case, the client tells the server that he speaks Netconf 1.1. So the hello start tag, hello end tag, and the capabilities part. We have a response from the server or the agent, if you want to speak SNMP lingo. It says Netconf 1.1. It tells the management system it has a writable running as well as a candidate. It can support confirmed commit. The client can ask the server to validate the data, and it can roll back on error. It tells the client that it has a specific Yang data model called DHCPD, and also a IETF data model. So this is the response, which tells the management system how to interact, which data models, which data stores, which Netconf version shall it use. Now we can do some get config. So a get config, stop, start. The source is the running, and a filter. So in this case, it's a filter to pick the AAA subtree. The response back is AAA, and down the tree here, we see the contents, and we get the lists of users. So the configured users in the system is responded back. An edit config. I'm targeting the running data store, the config part, and I would like to edit the default lease time. I would like to merge this lease time. So merges into the existing rather than replacing. And the server can respond with OK. If you look at the edit config, you can specify test options. Test and set is a default. Set without testing, and test without setting. There are error options, stop on error, not to continue, or roll back on error, would go back to the previous state. The actual operations you can do is to merge, replace, create, delete, and remove. And delete will fail if the item does not exist. remove is okay, although the item does not exist. We'll stop here and look at some live Netconf conversations using these operations. So I will illustrate the Netconf operations. We just looked at the get config and edit config. Again, I will reuse the very simple example we created in the part 1 of this tutorial. Simple device that has a properties container with a name for device and state. These are configurable states, note well. And an interfaces section where there are a couple of interfaces, and you can appoint one of the interfaces as being the management interface. So as you see here, this is the way our device is configured and displaying that on the local CLI. Let's do the same thing over Netconf. So here I have a Netconf browser, and as I did show you in the introduction, I could actually discover the data model and load the data model. So here's the tree structure of the same data model. Let's first connect to the device. What I do is say hello. So the client sends the hello to the server, and what's interesting here is that the server, namely my device with the box data model, responds to capabilities back. So you see one thing here, that the device tells the Netconf browser this is the data model, and a couple of other interesting here. We see that it supports a candidate database. There is no writable running, as you see. So there's a candidate, we have to write to the candidate. It can do rollback and error, it can do validation, it has a built-in XPath, so we can send XPath expressions, and you see some other modules here as well from standard IETF models. Let's start by doing a get config. So let's get the property section. Get from running. Note the structure up here. The source is running. We have a filter of type subtree. And the subtree is properties, the property section from the data model. Here we have the response, properties, name, and state. We can do the same for interfaces. We are getting from running, doing a subtree filtering for interfaces, and we get a complete XML response back with the 3 interfaces. And we also see the management interface that was appointed, the management interface ETH2. We can edit data. Maybe we would like to change the state. So remember, this was a configurable state, not a read-only operational state. Let's change the state. And we need to do an edit config. Note well that running is grayed out by the Netconf browser because the hello exchange told the Netconf browser that there's a candidate database and there was no writable running. If the capability of writable running would have been published, we could have done it directly to running. So let's modify the candidate database. So we're starting to build an edit config payload here. Edit config, target candidate, config/config. This is the actual configuration changes we would like to do. We would like to set it to good. Validate if that's an okay. Will work fine. Let's send as an RPC. Let's send the edit config as an RPC. What happened in the back here? The edit config was sent away. The devices responded with an OK. So what we did here is that we modified the candidate. So the running is not yet changed. In order to have this to take effect, we can send the commit operation. So commit copies candidate to running. And we can commit here. It was committed. Let's go back to the CLI and see if the state was changed. The state is changed to good. And previously it was bad. So that was a successful operation over Netconf. And we can of course do the same thing on a text-based Netconf client. We can start by doing the hello, returns the capabilities from our device again. We, for example, here we see the data model. We can do get the interfaces, or we can get the properties. We can also get a specific interface by doing the path interfaces / interface square brackets name equal eth0. Remember, name, that was the key in the data model, the list of interfaces. This gives us eth0 interface. So we will end the demo with deleting and creating interfaces. So what you have in front of you here is a netconf edit config XML snippet. So we have the edit config tag, end tag. We're targeting the candidate database and interfaces, interface eth1, but with a operation delete. So we can send that in any Netconf client tool. Here I prepared the same piece of configuration in the Netconf browser. Same thing here. And we could validate, but let's go send this as an RPC. So now I'm sending the delete towards my box simulator here. And we got an OK back. So this is now in the candidate, remember? So this was an edit config towards the candidate, and we can commit the candidate to the running. Changes were committed and the interface was deleted. So if I get all the interfaces with eth0 and eth2 while eth1 was removed. Let's go and restore. So creating config, let's just prepare the config and ask the Netconf server to apply the config. And send this guy, send it. We can commit it. Commit, and the interface should be back. eth1 is back. So that was a very simple scenario, deleting and creating config. This ends the Netconf session.